Imagine for a second a duck teaching a French class, a ping pong match in the orbit around a black hole, a dolphin balancing a pineapple. You probably haven't actually seen any of these things, but you can imagine them instantly. How did your brain produce an image of something you never seen? That may not seem hard, but it's only because we're so used to doing that. It's turned out it's actually a complex problem that requires sophisticated coordination inside your brain. That's because to create new weird images, your brain takes familiar pieces and assemble it in new ways, like collage from wicked project, where a juggle a sea of thousands of electrical signals, getting them all to their destination, and precisely the right time. We look at an object, thousands of neurons in posterior cortex fire, each equal very kept spiking fruit brown, green, and yellow. This synchronous firing strengthens the connection between the set of neurons, linking them together into what known as neuronal ensemble. In this case, the one pineapple in neuroscience, this is called the Hebbian principle. Neurons that fire together wire together. If you try to imagine a pineapple later, the whole ensemble will light up, assembling image. Dolphins are encoded by different neuronal ensemble. Area that's seen is encoded neuronal ensemble associated with this. The neurons work together by synchronized firing. But this principle doesn't explain the infinite number of objects that we can control intermediation without ever seeing. The neuronal ensemble for a dolphin balancing a pineapple doesn't exist, so how can you can imagine it anyway? One hypothesis, the mental synthesis theory, against time is key. If neuronal ensemble for dolphin and pineapple are activated at the same time, when precede two separate objects at the same single image, but something in your has to coordinate that firings. One possible candidate is prefrontal cortex, involved in all complex cognitive functions. Prefrontal cortex neurons are connected to the posterior cortex along pinnacle cell extension called neuronal fibers. The mental synthesis proposal like a puppeteer the prefrontal cortex neuron, so electrical signal down to neural fiber to multiple ensemble in the posterior cortex. They activate in unison and are turned on at the same time. You experience composite image just as you actually see this conscious purpose synchronization of different neurons and some by the prefrontal cortex is called mental synthesis. After the mental synthesis to work, signal would have to arrive in both neuronal ensemble at the same time. The problem, some neurons are much far away from the prefrontal cortex than others. The signal travel down both fibers at the same range. It arrives at the same. You can change the length of the connection, but your brain, especially as developed in childhood, down to change the conduction velocity. Neural fiber from bright fatty substance myelin, insulator, and speed up the electrical signal that's zipping down the nerve fibers. Some neural fiber has hundreds layers of myelin, others a few layers. A fiber with thicker layer of myelin can conduct signal 100 times faster or more than those with thin ones. Some scientists now think the difference in myelination could be key to uniform conduction time in the brain and consequent to our mental synthesis ability. A lot of this myelination happens in childhood, so from early age, and fibrin integration may have a lot to do building up brain with careful myelin connection in craft creative symphony throughout life. It's a symphony throughout life.